Let us look at 2017 number 5. Two particles move along x-axis. So from 0 through 8. For the first one, position for P has given to us this way. And then velocity for the second particle Q is given this way. And then particle Q is at position 5 when T is equal to 0. Alrighty. So let's try to look at this one together. So when is the particle P, the first one, moving to the left? Moving to the left implies that velocity of P has to be less than 0. So first I'm going to take the derivative of this. What is that equal to then? Meaning V of P would have been equal to, I need to take the derivative of this one. So the entire expression within the ln will go to the denominator, T squared minus 2t plus 10, and derivative of the inside will be on top. We get 2t minus 2. Now, then one thing that which we get to realize is that this one has to be less than 0. From 0 through 8, you get to realize that this denominator will always be positive. Because if you think about it, I can rewrite this one this way. T, let me write this one in 2 steps. T squared minus 2t plus 1. That's already perfect square, but we are adding 9 to it. In other words, this is equal to t minus 1 squared plus 9. So whatever t is, it's been squared, and then we are adding 9 to it. So therefore, denominator will always be positive. So therefore, what velocity for particle P would be determined by the numerator. Alright, so this one is always positive. So 2t minus 2 has to be less than 0. That means what? T is equal to 1. That's the value that separates the interval. And then when t is greater than 2, such as 3, then this is positive. So this portion is negative. But we are starting from 0. So that's the portion that which we end up getting. So it's moving to the left when t is greater than or equal to 0, but less than 1. All right, so let's look at part B. Find all time t during which the two particles travel in the same direction. So that means for the particle P, we realize that this is negative, this is positive. Let's look at particle Q. So I'm just going to set this one equal to 0. I'm going to use the different color. I get to realize that this can be factorable. So here we get t minus 5, t minus 3. And then that's basically what we're looking at. It has to be less than, or that's the velocity. So I could have 3, 5, and all the way up to 8, and then 0. Oops, 0. Now, I can plug in 1. If I were to plug in 1, I get 1 minus 8, which is negative 7, so it's positive. So it's positive here, that makes this one to be negative by alternation, and this becomes positive. They have to be in the same direction, so from 0 to 1, it's negative, but here it's positive, so it's not good. But 1 and up, it's always positive, so anything that's positive, that's beyond 1, they will have the same direction, so 1 to 3. So first case is 1 to 3. And then next one is what? 5 to 8. So those are the two things where they have same direction. Alrighty. Next, part C. Find the acceleration of particle Q at time t is equal to 2. And is the speed increasing or decreasing? All right, so let's try to look at that. Since in case of particle q, velocity is given, so we're looking at a of q is derivative of this one, so we get 2t minus 8. Now when t is equal to 2, we get to realize that that's equal to negative 4. So acceleration is negative 4 when t is equal to 2. Let's look at the velocity here from the blue ink here. When t was equal to 0, velocity was positive. You see that in the opposite signs. Velocity is positive, acceleration is negative, so it's going to be speed is decreasing because velocity is positive and acceleration is what? Negative. They have the same, they have different signs, that's why. Let's look at part D here. Find position of the particle Q. The first time it changed direction. It changed direction, that means velocity has to go from positive to negative or negative to positive. So in our case, it would have been 3 right over here. So we're looking for x of q of 3 is basically what we're looking for. But we realize that x of q of 0 is equal to 5. So we know x of 0, x of 3. So that's basically what we're going to do here. So in other words, 0 through 3 of v of q dt has to be equal to x of q of 3 minus x of q of 0. Now, then my left side becomes 0 through 3. The expression is t squared minus 8 t and then plus 15 dt, and then x of q of 3 is what I'm looking for, minus x of q of 0 was equal to 5, they told us. Then let's try to look at my left side here. So we get t cubed over 3. And then we have minus 4t squared plus 15t. That goes from 0 to 3. But at the end, we just have to add 5 to get x of q of 3. So when you plug in 3, then this one becomes 9 minus 36 plus 45 and minus 0, and then we're just going to add 5 from the last term. So then we get this one becomes 9, 18, 23. 23 should be the position of x of q of 3. So that's basically how we can finish this question. See you later.